So good day class, you are welcome to the second aspect of electrolysis. Today we are going to treat like 3 questions under this aspect. So, second law. So the first question we are going to treat is this. Calculate the mass of silver deposited when a current of 0.5 ampere passes through the solution of silver salts for 50 minutes. 50 minutes, giving us that the molar mass of silver is 108. So the solution. We are going to use this formula. M is equals to RML multiplied by IT divided by NL. Let's define our terms. M is mass deposited, or liberated at the electrode. RMM is the relative molecular mass of the given elements. I is current in ampere. T is time in seconds. So N is number of mole, and L is Faraday, the number of Faradays. So to use this formula now, let me claim all this now. The question is asking us to calculate the mass of silver deposited. So to know the number of Faraday needed for silver, we are going to write the reduction reaction as the cathode. Silver is going to gain 1 electron to give us a mole of silver. So the number of electrons involved is the number of Faraday we are going to use. That means we are going to use 1 Faraday. So we can then proceed to this formula. The mass deposited is what we are looking for. M is unknown. RMM has been given to be 108. 108 multiplied by I, which is time, which is correct. That is 0.5 multiplied by T, which is 50, but it's given in minutes. We are going to convert it to seconds. Multiplied by 60 divided by N. It is 1 mole of silver that was produced. 1 multiplied by the number of Faraday, that is 1. So that Faraday, we are going to use 96500. So if we solve that correctly, we are going to get 1.67 gram. That is the mass of silver that will be deposited. That's number 1. So this could be one of the questions on that first law. So the rest we are going to do will be under the second law. Now, second question. Number 2. An electric current is passed for the same time through solutions of silver nitrate, H2SO4, sulfuric acid, and copper solvents connected in series. If 5.4 grams of silver are deposited on the cathode of silver electrolytic cell. At STP, calculates the mass of copper deposited, giving us that silver is 108 and copper is 63.5. Now the question is on mass of copper, but this is a series connection. The same amount of current we pass through the 3 electrolytic cells. You are given silver nitrate, H2SO4, and copper solid. So, but there is no information on the amount of current and time given. They just told us in the question that an electric current is passed at the same time. So that current is not mentioned, and the same time is not mentioned. We remember that Q is equal to IT. So we just need the Q. Now, the only information given to us now is 5.4 grams of silver. So from the silver given, we can calculate the quantity of electricity that deposited that 5.4 grams of silver. So we can know it because silver is Ag plus electron, giving us silver, 1 mole of silver. So since we know that 108 grams of silver required 96500 coulomb. How many coulomb with 5.4 required? Therefore 5.4 grams of silver will require X. So we have X is equals to 5.4 multiplied by 96500 divided by 108. When we solve that, we are going to get 4825 coulomb. So this is the quantity of electricity that was used. So the same quantity of electricity will be needed for H2SO4 and copper solvent. We can now proceed to solve the question. So the question is asking us to calculate the mass of copper deposited. So we need this 48. Q is given to be 4825 coulomb. So every other things has been given. So using the normal formula, using M, which is mass deposited, is equals to RMM multiplied by Q over NF. How many Faraday do we require for copper? We are going to write cathodic equation, which is the reduction reaction. Copper is going to lose 2 electrons. When it gains it back, that is 2 electrons into copper. So 2 electrons we gained, and that means we need 2 Faraday, which is the same thing as 2 times 9,6,500. That is what we are going to use. So let's put everything into the equation. M, mass of copper deposited, is equals to RMM has been given, relative molecular mass. That is 63.5 multiplied by the quantity of electricity that has been calculated. That is 4825. I hope you remember anytime the electrolytic cell is connected in series and they didn't give us the quantity of electricity, we can calculate it from the one given because the same current will pass since they are connected in series. That is why we have done this before. So we are now using it. So divided by N, which is 1 mole of copper that was deposited, 1 multiplied by 2 Faraday, that is 2 times 9,6,500. So it means we must be able to write the cathodic equation to know the number of Faradays needed for any calculation. So if we solve that one correctly, we're supposed to get 387.5 divided by 19300. Then we are going to get 1.58 grams. That is it. So any question given under electrolysis, be it under the first law or the second law, this formula will solve it easily. Let me give you this as an assignment. You can reach out to me on the email or you comment under the comment section of this video. I'm going to reach out to you. Let me write this. This is the question. Do this. A steady current flows through two electrolytic cells connected in series containing solutions of copper 2 chloride and silver triazonitrates 5 solution respectively. If 10.25 grams of copper were deposited in the first cell. The first cell was mass of silver was deposited in the
second cell. Given that silver is 108 and copper is 63.5.
This question is similar to the one we have done before. If you look at it very well, information about the current and the time, which is Q, is not given. So you are going to use this one, 10.25 gram of copper that was deposited. So you are going to use that to get the information about the Q. Then you now use the formula. That's it. Please don't forget to like and subscribe to this channel for our subsequent videos. Thank you. Bye-bye.